Okay, in the last video, we figured out what our model was going to be. We decided that we're going to use sales quantity and freight, and we're going to run this particular model. We got the code for that. So here we're going to save this as the model, which is an ordinary least squares regression between our y variable or our dependent variable freight and our independent variable sales quantity. We wanted the results to go for this model. So we want to know what the results. So give me the fit. That's a function within this overall package. And then I want to and this is going to give me the results, RES, and then print RES and give me the summary. All right. So what I did over here is I got the results. I copied it, and I'm going to paste those into our script here, just so we can take a look in a little more detail. All right, so this is what the output is. So this is the output of the print res dot summary. Okay, that's what the output is. All right, so let's take a look at what we see in here. All right, so if you got to go back to your understanding of regression. So the R squared, specifically the adjusted R squared, it looks like sales quantity explains around 93% of the variation of freight, right? That's pretty good, right? So I can say with a high degree of confidence that as my sales quantity increases, my freight is also going to increase. And of course, that makes very, very good business sense, right? I can say that the coefficient of sales quantity, remember this is by bottle, the coefficient of sales quantity is equal to 5 cents, a nickel. So the interpretation here is that a single bottle sold roughly accounts for 5 cents of freight expense. Okay, that might be very useful to evaluate in the, looking at year over year, has that coefficient changed? Or maybe I want to look at an individual store and see if now the problem is we could, but I don't think you can. But if we had freight broken out by store, maybe we could see, is there different freight costs for each of the individual stores? Maybe I want to look at this coefficient year over year to see if there's any significant change in it. So I might have, I don't know, we can always talk about creating dummy variables. So for each year. So there's lots of different things that you can start kind of thinking about. If you just wanted to get the output for certain elements, you can use some instead of printing this all out, right? If you want to get certain elements, RESPARAMS, to output the parameter estimates. And in this case, basically the 5 cents per bottle. Or the adjusted R squared. Right, we can do res dot R squared underscore adjusted, right? And if you want to know what all the full list of attributes are, going and putting in dir for your results. All right. Again, you've labeled it results. All right. So just to kind of show off some of that stuff, let's put in res param. All right. And then see what we get from that piece of code. So that just gives me my sales quantity and tells me what the data type is. Maybe I want res r squared adjusted. Right? That should give me that my 0.933 up here. No, you gotta actually not have a typo. R squared 0.93268, right? And here's your, we'll do the directory of your results, right? And run that. Those are all the, that's the directory of all the different results that you can output, right? Now, if I name this results, all right, then I'd have to change all of these to give me results parameters, right? Because I changed the value of, and this would have to be results summary, right? Because I've defined this as results, and it would give me the same results summary. So res doesn't mean anything. It depends on what you end up calling this, what you end up calling your results in the first place. Right, and we're just calling it res. All right, and then now it comes the hard part. Right, it comes down to, all right, what does all this mean, and what does the decision maker want to make? What does the decision maker want to find out about it? All right, if you wanted to add more independent variables, so maybe you want to use multiple regression, right? We're just using simple linear regression. You could create a data matrices right? So go to the following link to get started, right? Because this link is going to help you figure out how to use stats models and add more variables if you want, right? You can also define X with multiple variables and then put in X to the sm.ols. All right, so we don't have the variables all set up, but this is the way it would look. We'll say X is equal to, and then we'll put in our variables. So it's going to be df summary, and in this case it's sales quantity, and then maybe we also put in df summary, and then we also have sales dollars, right? So we want to see if there's any relationship. That's our X matrices. And then what I would do is I would put in up here, I would put in my freight variable, and then I would put in X, and then that would get, and then I would put in, that would tell me that I am regressing freight on X, and X is a matrix, is two variables sitting as defined in X. But go to statsmodel.org and start exploring what are some of the more advanced models that you could potentially utilize. But you got to go through all this logic up front to see whether or not the method you're choosing is the right method.